Welcome to the DIY Honda Garage channel. DTC P0222 indicates a low voltage condition in the throttle position TP sensor B circuit of the Honda Civic models from 2006 to 2011. The TP sensor is integral for measuring the throttle valve position, which aids the engine control module, ECM, in adjusting engine performance accurately. It influences fuel injection and ignition timing, ensuring optimal engine efficiency and reduced emissions. A faulty TP sensor can cause performance issues, as it leads to improper readings that affect the engine's operation. The TP sensor B is particularly important as it works in tandem with TP sensor A to provide the ECM with precise data. Understanding this DTC is crucial for diagnosing and repairing potential engine management problems. In the context of DTC P0222, the throttle position TP sensor B is a critical component located at the throttle body of the vehicle. Its main role is to measure the position of the throttle valve, essentially being the vehicle's sensing eye for how open or closed the throttle is during operation. This information is vital as it allows the engine control module, ECM, to manage fuel delivery and ignition timing effectively. A malfunctioning TP sensor B can cause erratic engine behavior, affecting performance and fuel efficiency. Therefore, understanding its placement, function, and potential issues associated with it is essential for effective troubleshooting. Inspecting the sensor for electrical connectivity and integrity is a primary step in the diagnostic process. The possible causes for DTC P0222 include a few common electrical issues. Poor connections can lead to inadequate signals sent to the engine control module, causing low voltage readings. Additionally, loose terminals can disrupt the electrical flow necessary for the TP sensor B to function correctly, leading to anomalies in its output. A short circuit in the wiring between the throttle body and the ECM could also exist, preventing accurate voltage levels from being transmitted. Lastly, a malfunctioning throttle body itself could result in a faulty TP sensor B reading, emphasizing the importance of testing each component and connection methodically. Diagnosing these causes effectively will guide toward fixing the problem adequately. Symptoms of DTC P0222 often manifest as erratic engine performance. Drivers may experience poor acceleration, where the vehicle does not respond as expected when the gas pedal is pressed. This indicates that the ECM is not receiving accurate data from the TP sensor B, which is critical for adjusting fuel delivery. In addition, fuel economy issues may arise, as the incorrect interpretation of the throttle position can lead to overfueling or underfueling conditions. As such, these engine performance variations can create further long-term damage if not addressed promptly. Monitoring these symptoms is crucial for diagnosing underlying issues effectively. Start troubleshooting DTC P0222 by first turning the ignition switch to the on-to position. This powers the vehicle's electrical systems without starting the engine, giving access to the electronic control systems. It's important to record all freeze data, which captures specific conditions at the moment the fault was logged. Reviewing any onboard snapshots is essential, as these can provide insights into the engine's operations leading up to the failure. Gathering this data is foundational for subsequent steps, allowing for a more informed diagnostic process. Don't overlook the importance of understanding initial conditions and previous fault history data before continuing. The next step involves clearing the Diagnostic Trouble Code, DTC, using the Honda Diagnostic System, HDS. This can help reset the vehicle's electronic systems, removing any stored codes that could interfere with fresh diagnostics. After clearing the DTC, it's essential to confirm that there are no additional trouble codes present in the system, ensuring that the focus remains solely on the P0222 code. This step is vital for establishing a clean slate for diagnostics, as it helps to rule out any previous issues that may be lingering in the vehicle's memory. By focusing on the current concern, technicians can be more efficient in their troubleshooting efforts. In this step, utilize the HDS to check the TP sensor B within the data list. By measuring the voltage output, it's essential to observe if it shows about 0.3 volts or less. A low voltage reading indicates a circuit issue that needs further investigation. However, if the reading doesn't reflect this, it suggests that the system is temporarily functioning correctly. In such cases, intermittent failure may exist, pointing to potential intermittent issues like poor connections or loose terminals at the throttle body and ECM. Understanding this step is crucial, as it can lead to uncovering underlying causes affecting normal operation. Proceeding effectively depends on accurately interpreting the sensor's voltage readings. Using the HDS again, the next step involves checking for any pending or confirmed DTCs. It's important to see whether the P0122 DTC appears alongside P0222, as this combination can indicate a more systemic problem in the throttle position sensing system. If both codes are present, it necessitates further investigation into what might be wrong specifically. Conversely, if P0122 is absent, it indicates that the system is likely functioning correctly for now. This step is crucial for identifying linked faults within the throttle position sensing systems and direct subsequent troubleshooting. Properly diagnosing this relationship will likely lead to a swift resolution. After checking for additional DTCs, turn the ignition switch to the lock 0 position. This step is necessary to ensure safety before performing any electrical disconnections. By powering down the vehicle fully, technicians can prevent accidental short circuits or electrical shock. It's now time to prepare for disconnecting the throttle body 6P connector, an important step that allows for further investigation of the system components. This process might seem straightforward, but ensuring everything is powered down is essential for safe handling of vehicle components. Following this precaution will set up the next steps for continued diagnostic accuracy. Disconnecting the throttle body 6P connector is the next action, allowing for a closer examination of the connection and wiring integrity. Handling the connector requires care, as it plays a pivotal role in transmitting signals between the throttle body and the ECM. This thorough examination can highlight any potential disconnections, shorts, or corrosion that may impact the TP sensor B performance. It's vital to double-check that safety measures are in place when performing this step, including working in a well-lit area and taking precautions against static discharge, as this will preserve the integrity of sensitive electronic components. Completing this task accurately is vital for determining the state of the throttle body connection. In this step, jumping the SCS service check signal line using the HDS allows for the diagnostic system to enter a specific testing mode. This procedure is essential for isolating the electrical condition and checking for potential faults more effectively. By creating this connection, technicians can bypass certain circuits to focus on the task at hand, ensuring that readings from the TP sensor B are accurate. This momentarily alters the circuit dynamics, providing clearer data on the sensor's function. Without this step, important signal discrepancies could go unnoticed, delaying the troubleshooting progress. Taking this thorough approach prepares the technician for pivotal electrical checks ahead. Next, disconnect the ECM connector C, which has 44 pins, to access the internal connections within the engine control module. This step is crucial for diagnosing any faults between the throttle body and the ECM. By examining the connections at the ECM, technicians can identify potential issues such as corrosion or bent pins that could disrupt electronic communication. Access to the ECM also permits checking continuity and integrity of the electrical pathways involved in the throttle position sensing process. Keep in mind that connectors like this are sensitive to handling. Ensuring no damage occurs during the disconnection is paramount. This step enhances the overall efficiency of the diagnostic process and aids in pinpointing electrical faults. Now it's time to check for continuity between throttle body 6P connector terminal number 3 and body ground. This test is vital for verifying that the electrical pathway is intact and functioning as intended. Use a multimeter to check continuity across the designated terminals, as this will indicate whether there's a solid connection to body ground. Identifying continuity confirms that the wiring is intact, allowing for the necessary signal flow. If continuity is present, it indicates no short circuits in the wiring between the throttle body and the ECM. Thus, repairs can proceed accordingly. However, if there's no continuity, the next steps involve diagnosing wiring issues that could greatly impact normal operations. Mastering this testing is essential for accurate conclusions in the troubleshooting process. In this pivotal step, measure the voltage between throttle body 6P connector terminal number 2 and body ground. Ideally, this should show a reading of around 5 volts. This voltage is typically delivered to power the throttle position sensor B, and any significant deviation from this indicates possible issues with the power supply or sensor itself. If this voltage measurement is within the expected range, the next steps can focus on inspecting the sensor's performance. If the voltage reading is below the expected level, it's potentially indicative of supply issues from the ECM or a short within the wiring harness. Understanding these voltage readings clarifies root causes for faults noted in the DTC P0222. A systematic approach to this measurement complements the overall troubleshooting efforts. After performing the necessary repairs, the next stage is to verify that everything works as intended by clearing all diagnostic trouble codes, DTCs, once again. This helps reset the vehicle's system and allows for fresh diagnostic readings free from older codes. A critical part of this verification process involves taking the vehicle for a test drive. During the test drive, observe the vehicle's responses to different accelerations and loads to ensure that the TP sensor B operates efficiently. Monitor the dashboard for any reoccurrence of the P0222 code or any other related DTCs. This final verification is essential to confirm that all repairs resolve the issue and that the vehicle is safe for regular use. Validating repairs before concluding will ensure long-term effectiveness. Preventive maintenance is crucial in avoiding future occurrences of DTC P0222 or related faults. Regularly checking connectors for signs of wear or corrosion can help maintain optimal function. Electrical connections that are loose or corroded can lead to issues in the throttle position sensing system if overlooked. Additionally, inspecting the wiring for any abrasions or damage helps ensure that continuous electrical flow remains uninterrupted. An environment free from moisture and debris around electrical connectors can significantly reduce the risk of failures. Establishing a regular inspection schedule contributes to the longevity and reliability of the vehicle's performance. Being proactive leads to cost savings and prevents potential breakdowns. In conclusion, understanding the role of the throttle position TP sensor B is key to diagnosing and fixing DTC P0222. Through methodical troubleshooting, technicians can pinpoint issues effectively, from checking voltage levels to ensuring connectivity. Implementing clear and structured diagnostic steps allows for accurate repairs while minimizing downtime. Additionally, routine preventive maintenance can greatly lower the chances of encountering such DTCs in the future. Ensuring that connectors and wiring are in good condition is essential for long-term vehicle reliability. Overall, combining knowledge and systematic approaches leads to successful diagnostics and enhanced vehicle performance. Please like and subscribe to the channel. See you next time!